Today, I'm going to talk about a very important concept from machine learning, and it's called the confusion matrix. Before we start, let's understand what is a confusion matrix. A confusion matrix is a table which is used to evaluate the performance of a classification model in machine learning. It summarizes the prediction of the model against the actual value, showing how often the model correctly and incorrectly classifies the instances into different categories. So let's understand this with some examples. So let's check this example. I have a data set where I'm dealing with the month, the sunny, whether the day is sunny or not, the season, and whether there is rain happened yesterday. And based on this data, my model is trying to predict whether I should carry umbrella or not. So this is one example. This is a month of January. It is a sunny day. Definitely the season is winter and there is some rain happened. Rain means like snow happened yesterday. So I definitely should carry umbrella today. This is what my model is predicting. Now the another example is December. It's not a sunny day. It's definitely a winter and there is no snow happened yesterday. But since it's a December, my model is predicting I should carry umbrella. Similar way, another example is October and it's not a sunny day, it's autumn and there is no rain happened. So I can continue, I can go outside without carrying umbrella. So this is an example of the data and my model is trying to predict whether I should carry umbrella or not. My model is trying to predict two values, whether I should carry umbrella or not. So the outcome is 2, either yes or no. So now if I plot this inside a confusion matrix, this is how my confusion matrix will look like. So since my model is trying to predict two values, yes or no, so my confusion matrix is going to be a 2 by 2 matrix, as you can see here. As you can see in the confusion matrix, I have plotted need umbrella, doesn't need umbrella. Also on the row wise, need umbrella and doesn't need umbrella. So this side is basically the actual values and this side is basically the predicted values, what my model is going to predict. So always the column wise, like column wise, it is getting the known truth, and the row wise, like this row and this row, is telling the predicted value. Now, if you see, this section is called the true positive. Why is called the true positive? The reason is the known truth or the actual value is that I should continue, I should go outside with umbrella. It means I need umbrella. And what my model is predicting? My model is predicting also that I should continue with umbrella. I should go outside with umbrella. So the actual value and the predicted value both matches. That's why it's called the true positive. Similar way, if you see, this section is known as a true negative. Why it's a true negative? Because the actual value is telling I don't need umbrella. And what my model is predicting is exactly the same. I don't need umbrella. So my model prediction and the actual value matches. That's why it's called the true negative. Now, if I leave the true positive and the true negative, let's continue with this section. This section is called the false negative. Why is called the false negative? The false negative is that the actual value is telling, or actual value is that I need umbrella. But what my model is predicting is that I don't need umbrella. So what my model is predicting is basically a negative, but it's a false negative because in reality I need umbrella. So that's why it's called the false negative. Similarly, this section is called the false positive. Why is called the false positive? The reason is my model is predicting that I need umbrella, but in reality I don't need umbrella. So what my model is predicting as positive is actually not a real positive. It's a false positive. That's why it's called the false positive. So this section is called the true positive, or in short TP, and then true negative, which is TN. False negative is FN and false positive is FP. False positive, this section we call this as a type 1 error, and false negative we call this as a type 2 error. Okay, so far so good. Let's continue with a more complex example. This example is telling the taste. This dataset is all about taste. So sweet, spicy, sour and bitter. Depending on the taste, my model is trying to predict what is the favorite food of that person. There are 3 choices: hot and sour chicken, sour curd curry, or fried pork chop. So depending on the data or depending on the type of test, my model is trying to predict what is a favorite food. Now, compared to the previous example, in this time, my model is trying to predict 3 values: hot and sour chicken, sour curd, or fried pork. Since it's trying to predict 1 out of 3, so this time the confusion matrix will be a 3 by 3 matrix. And this is what the confusion matrix looks like. Before I continue with this confusion matrix, I should tell you something. For that, I am going back to my previous example. If you see this example, you see the true positive and true negative, I have marked them in green, whereas false negative and false positive, I have marked them in red. There is a reason behind that. The reason is true positive and true negative. This is the indication that how many times my model has correctly predicted. So this is a correct prediction. Whereas this red, Fn and Fp, the false negative and the false positive, this is an indication that how many times my model has incorrectly predicted. So in a confusion matrix, this is a very important thing. So always the diagonal is the one which indicates how many times my model has correctly predicted. Rest everything is like how many times my model has incorrectly predicted. So this is very important thing to understand. So now going back to the 3x3 matrix, it's the same thing. Always the diagonal one, I mark them as green because this is what is telling how many times my model has correctly predicted. Rest everything's are marked as red because that's telling how many times my model has incorrectly predicted. So what we have learned that size of the confusion matrix depends on the number of choices that my model has to predict. So if my model is going to predict between 2, the confusion matrix is going to be 2 by 2. If my model is going to predict out of 3, then my confusion matrix will be 3 by 3. Diagonal is the one which is going to tell me how many times my model has correctly predicted, and rest everything is telling how many times my model has incorrectly predicted. And the true positive is the one where my model prediction is positive and the actual value is also positive. True negative is the one where my model prediction is negative and the actual value is also negative. False negative is the one where my model prediction is negative, but in reality, it's actually a positive. That's why it's called the false negative. Similar way, false positive is the one where my model prediction is positive, but in reality, the real value is negative. So that's why it's called the false positive. Okay, with that, the next section which I am going to explain you is what are the different matrices that you can get from this confusion matrix. The first one is accuracy. So what is accuracy? The accuracy is actually the measurement of the overall correctness of the model. It is the ratio of the correct prediction to the total number of prediction. So if you see, the correct prediction is the true positive and the true negative, and this is the total number of prediction. So the ratio between these two is called the accuracy. Next matrix is the precision. So what is precision? Precision is a measurement of accuracy of the positive prediction. Of all the prediction for the positive classes, how many were correct? So if you see, this is a true positive, that is a positive prediction, and this is the true positive and false positive. False positive means this is the time also where my model has predicted positive. So out of all the positive prediction, how many are actually positive? That's what is called the precision. Similar way, it's a recall. Recall is the model's ability to find all the actual positive samples. Of all the actual positive instances, how many did the model correctly identify? That's what is called the recall. And the last one is the F1 score. So F1 score is nothing but, as you can see in the screen, it's basically a harmonic mean of precision and recall. And this is the formula of the F1 score. So let me give you a scenario where precision is very important. Let's say you are going to build a model or you are going to train a model, and the intention of the model is to identify the spam email. Now, it is very important that your model should be very precise so that you don't mark any important email as a spam email. You should only mark real spam emails as a spam email. So what does it mean? It means the cost for a false positive is very high here. So in this type of scenarios, precision is the matrix that you should look for. Similar way, let me give you another example where you are going to build a model where the model intention is to find out all the patients who actually have the diseases. Basically, the model is going to be used in a medical screening for a disease, right? So in this type of scenarios, your model should find all the patients who actually have the disease. Even it means that some healthy patients are flagged for some more test. So what does it mean? So it means when the cost of a false negative is very high, that point of time, you should always use the recall. That's the matrix that you should look for. Okay. With that, This is random numbers I have given for the true positive 98, 13, 36 and 34. Using this number, this is the way how you can calculate the accuracy. The accuracy is coming from 0.73, recall is coming as 0.73, precision is 0.88 and F1 score is coming as 79. So that's all for today. Even though the name is a confusion matrix, but I believe after this video you should be able to understand the basic concepts of confusion matrix and why it is so important. If you like this video, please share this video with your friends, with your colleagues, and if you think this video is helpful, please hit the like icon, consider subscribing to my channel, and don't forget to hit the bell icon so that next time when I'll publish more videos on this type of topics on machine learning, data science, you'll be the first person to be notified. Till then, stay safe. Thank you. Bye bye.